What is memory? It's our capacity to learn and use new information. It's the parts of our past that make us who we are. But it's also a whole lot more.
The implication is that some of what you are is what your father and mother experienced.
Even into your adult years, there is the propensity to change the way that the brain develops.
The brain's amazing how complex it is and how many neurons can be found in such a small area.
In this episode, I look at how our memories change from childhood to adulthood and the best ways to power our mind into old age.
Then Goldilocks sat in Mummy's chair. It was very fun.
This is me, reading a book, aged 3.5. It's the first time I've ever seen this footage, and nothing about it is familiar.
She flopped down on the floor and broke it.
But these images from just a few years later flood my brain with recognition. I remember the name of the beach, the coldness of the water that day, even how I felt. Apparently, that's pretty standard.
Well, Sigmund Freud called this infantile amnesia, that you basically can't recall the first 3 to 4 years of your life as an adult.
Even though I can recall much of my life after 4, I can never remember where I put my car keys, what I did last week, and what's this guy's name again? Bye. Sometimes my memory seems so wonderfully obedient, and the rest of the time so atrocious it feels like I'm losing my mind. Is that cause for concern, or just a case of brain overload? The brain is our hungriest organ. Although it makes up only 2% of our body weight, this greedy mass of white and grey matter is wolfing down 1/5 of our energy just processing our normal daily tasks. In newborns, their brain uses a whopping 65% of their energy. But doing what exactly? Most of the time, they're asleep. What's his name?
George.
Hello, little baby George. At this age, the baby's brain is going through huge changes, making new connections at an astonishing rate. You could think about it a bit like a village full of houses, but with no roads, transport or infrastructure. And it's very busy building all those pathways. No one's really sure why babies sleep so much, but new research suggests without frequent napping, they're unable to consolidate memories. And without memories, you can't learn.
I'm just going to place the head coil on now for you.
Yep.
And this is going to allow you to be able to see the task once you're inside of the scanner.
By the time you get to my age, memory is a well and truly sophisticated process.
Are you going there, right?
Yep, good.
Okay, this one just goes 4.5 minutes.
So just remember as much as you can in as much detail as you can, OK? OK, thanks.
In this functional MRI, commands are appearing on a small screen in front of me, asking me to remember events from my past. As visuals and thoughts flood my brain, the scanner is picking up which regions engage and which don't. Thankfully, quite a few areas lit up.
Here we have the parietal lobes, and what that's associated with is the idea that you're putting information together. So it might be that you're visualizing something, you're getting words, you're getting sounds and emotions, and it's putting it all together. Another area is this area here, which is in the occipital lobes, and that's associated with you visualizing things. So when you're recalling the memories, the area of your brain which is thought to be all about visualizing the actual event is lighting up very strongly in you.
Yeah, because when I was remembering things, I was visualising a lot. There was just picture after picture going through my brain.
So this area here, at the front of the brain, in the frontal lobes, basically it's showing that you're actually searching for the memories that you're being asked to recall. OK, if you could get on bed for me.
Janine's research looks at how children's autobiographical memory differs from adults. Michaela is a young adolescent, and she's given exactly the same memory tasks as me. The areas in red show Michaela's activity. You can see considerably less of her brain is involved in recall, most noticeably in the frontal lobe.
And what we're thinking that is showing is that the child is yet to be able to develop that consistent search process. They'll be searching, but for a far more limited time than maybe an adult would.
A person Michaela's age doesn't have as big a reference library, and their identity is still developing.
As you get older, you start to associate events with emotions, but also the sense of self improves as well, the ability to know who you are. Quite often what we find is that children recall the gist of an event, unlike an adult, which will probably have a far more rich, self-aware recall.
That lack of self-awareness is nowhere more apparent than in a toddler, especially if you try to play hide and seek.
They believe when they cover their eyes that nobody else can see them, and that's because they haven't yet developed the sense of self. They think what they see is what everybody else sees. So as you develop the sense of self, you're also able to imagine yourself outside of everybody else, so you get a first-person perspective.
And this is one of the theories behind infantile amnesia, that we can't recall memories from a time when we weren't self-aware.
There are other theories which are biological, so that the structure of the brain is not yet at a point where it can do the functions that are required to recall autobiographical memory.
Although many different brain regions are involved in recall, there's one part that you can't make memories without.
So this is a healthy brain. You can see the grey matter is actually outlining here, and inside those grey matter areas are all the neurons that allow us to do all our thinking. And then if you zone in just here, you can see the hippocampus, which is this structure here with a kind of curled appearance.
So this is where memories are formed, is it?
So this is the actual really big centre for where memory occurs in the brain, along with other functions.
It's quite small, isn't it? I would have expected, with, you know, a part of the brain with so much work to do, to be bigger.
Yes, I know. The brain's amazing how complex it is and how many neurons can be found in such a small area. I mean, there would be loads and loads of neurons here in a normal brain.
There are an estimated 86 billion neurons in the average brain. They send messages to each other via electrical or chemical impulses down a long tail called an axon. These form synaptic connections with other neurons, creating brain circuits through which a mind-boggling number of messages can travel. Professor Katrina McLean investigates the neuropathology of various brain conditions. Deterioration of neural networks in the hippocampal region is a typical sign of a brain disease involving memory loss.
If it's a patient with Alzheimer's disease, you see lots of neurons, which are the kind of central core structures that allow us to do all this integration. They're lost, they're gone.
Just a couple of decades ago, it was thought that the brain could only deteriorate with age. But we now know that, especially when we're younger, the hippocampal region can generate new brain cells. It's called neurogenesis, and it's another theory behind infantile amnesia.
And that basically is about the idea of the memory centres in the brain, or the hippocampus, forming many new neurons throughout the first 3 to 4 years of life. And with each creation of new neurons, they're wiping away those memories that have been laid down before.
It's no fluke rampant production of brain cells in infancy coincides with a prolific stage of learning and development. Although the rate of neurogenesis is thought to drop dramatically after the first few years of life, there's still hope for us older folk to boost our brain reserves. It was a famous study of London taxi drivers 15 years ago that turned concepts of the adult brain upside down. Cab drivers there have to pass one of the most difficult licence tests in the world, memorising more than 25,000 streets. It's aptly called the knowledge.
Over 4 years, they looked at the changes in the structure of the brain in the hippocampus. And what they found is that in the taxi drivers who passed the knowledge, there was actually a larger area in the rear of the hippocampus.
The longer they'd been on the job, the larger their hippocampus grew. Interestingly, bus drivers showed no change in their brain, most likely because they operate on preset familiar routes and don't need to memorise new information. At the Florey Institute, adult mice have been helping scientists understand exactly how a novel and rich environment can enhance memory. These mice have the ultimate playground. They've got a running wheel for exercise, they've got puzzles to solve, and they've got things to look, touch and play with. These other poor mice live in Dullsville, with very little stimulation of any sort except company and food. Professor Anthony Hannon and his team have been studying the brains of these two groups of mice and at a microscopic level have observed big differences.
With increased cognitive stimulation, physical activity, we get increased birth of these neurons in this part of the brain called the hippocampus, which is very important for memory. But the effects can be quite dramatic.
The mice in the enriched environment also show big increases in the number of connections between neurons.
And it seems that the cognitive stimulation, by stimulating the networks, increases the level of survival of those adult-born neurons. That's why you need both. The exercise alone seems to stimulate them to divide and create more, but the cognitive stimulation keeps them alive and forms them into functional networks.
But does it improve their memory? The same two groups of mice have been put through different mazes to find out how fast they can find their way home. One of these holes has a nice, dark, safe box below, and this mouse is using objects around the room to find it.
And what we know is that when you actually house animals in an enriched environment, not only are they 50% faster in finding the location of that tunnel, they actually use these different strategies in a more efficient manner.
So his memory is better?
His memory is actually better, and he will actually retain that long-term memory for longer. Try and find... He's found it right there. There he goes. Fantastic.
Although a stimulating environment is important for improving memory, there's something else happening in between which is crucial. Sleep. While wakefulness is used for encoding our memories, it's thought sleep reactivates and transfers the gist of what we experienced to longer-term neural networks outside the hippocampus. When we repeat an experience, like practicing a skill, the white matter in our brain also changes. The substance surrounding the long tail of our neurons thickens, helping messages travel faster and stronger. As we improve and attention networks become more and more efficient, other areas of the brain get involved, allowing creativity to flourish. So when we hear the adage, practice makes perfect, it's really all about the brain changing as you develop your skill. So why do we so often forget what is most mundane and familiar? Like where we put our car keys. Hello, Michael.
Hi, Anya.
Professor Michael Saling is a memory clinician who often sees people like me who fear they're losing their mind.
I'd like you to describe to me what it is that you notice within yourself.
I'm always losing things momentarily. I leave my scripts behind, my pens behind. I can't remember whether I've taken things with me or not, and I'm always pulling out my bag. It's kind of embarrassing. I can be driving my car and think I left my car keys at home. So I just wonder if it's in my genes or something more serious. Michael has been increasingly seeing people in my age group. Most often they're not actually suffering real memory decline, but instead a form of stress.
We use the word worried well. It's actually a common word used in the clinical world for people who are well but who are concerned. They tend to be people in their 30s, early 40s, who are actively working, who lead busy modern lives, who are plugged into the media, and to all intents and purposes may be suffering from an information overload.
You can think of selective attention like a small window. Even though the space in the brain is a virtually unlimited storage facility, you've got to focus on what's going on outside that window to actually record the memory. Ruminate on problems inside your head, and that window of selective attention shrinks. So I haven't actually forgotten where I put my keys, I just didn't pay any attention in the first place.
People will very often say, I'm just not good at remembering names, completely oblivious to the fact that something happens as they're being introduced to someone new, which could be excessive self-awareness, social anxiety, attending to something else at the same time. Other people put more effort into concentrating on the person and the name.
What's very often the issue when people forget are the limitations of our working memory, which is kind of like a short-term mental workspace. It can only hold around 7 pieces of information at any one time.
If you can remember the beginning of my sentence by the time I get to the end, that's approximately the span of that system. That's an important aspect of its function. And after that sentence, it'll quickly refresh itself, waiting for the next bit of information to come in. So that's where the vulnerability very often lies in people who do not have brain disease but are subject to interference.
As I'm asked to remember the names of basic objects during my clinical test,
Octopus.
I'm slightly embarrassed I thought I had a serious memory problem.
Cone. Otter, a beaver. I think.
I certainly don't forget where the keys are or other random objects.
The coin is behind the coffee cup, the paper clip's in the drawer, the key is behind the printer, and the calculator is behind the desk.
Okay, so there's that pen. What I'd like you to do for me is just to draw the face of a clock.
If I had a memory condition, my sketchy version of 10 past 11 might look more like this or this. But of all the tests Michael is interested in, word recall tops the list.
Turkey, farmer, hat, school.
How many words I can remember from 15 is a test used the world over.
Drum, bell, curtain. I think turkey. I think I've got it.
Right, Anya, so how do you feel after that?
I think I did okay on... I'm not quite sure how I did on the word test. I did very badly, I think, on one of the word tests, but you tell me.
Well, in reality, you did extremely well.
As Michael suspected, my forgetfulness during the day is simply because my overworked brain does what it's supposed to do: forget.
If we were to retain all of the information we encountered in the course of a day and remain aware of it, we would be very disabled in daily life. Forgetting is normal.
But in Alzheimer's, the forgetting is anything but normal.
Mum, we've got to get to the doctors. Can you jump in the shower for me? I'm just going to make a few phone calls.
This virtual reality program is designed to help carers understand what life is like from a sufferer's perspective.
There's a hole in the floor. No, there's not, Mum. We're going to be late. Can you please hurry up?
It's terrifying. Even the most basic concepts become alien. Close to 1 million Australians will live with dementia by 2050, with Alzheimer's being the most common cause. But what causes Alzheimer's? It's a question Professor Chris Rowe and his team have been focused on for years.
We think the first thing is the formation of these amyloid plaques, and they keep building up.
This is a PET scan of a healthy brain. And this is one full of amyloid beta plaques, a damaging protein which accumulates between brain cells.
After this situation's probably been running for 10, 15 years, the little bit of brain shrinkage starts to creep in. Then on sensitive memory tests, you can show people's memories declining, even though they're not aware of it themselves. Then about 5 years before somebody gets to the stage of dementia, they notice a pretty serious memory problem. And then over about 4 or 5 years, they get worse and develop dementia.
The amyloid plaques appear to encourage another brain protein called tau to form fibrous clumps inside your brain cells. This derails the brain's message transport system and neural networks effectively disintegrate. Tau tangles appear first in the hippocampus and are closely correlated with memory decline.
The amyloid plaques actually accumulate all over the brain, and so it's a bit of a mystery as to why this hippocampal region of the temporal lobe is particularly affected.
Now a huge international trial hopes to halt the progression of Alzheimer's before noticeable symptoms occur.
I'd like to ask, why have you volunteered for this study?
This disease is such a long road home that I'm just hoping something can be done. So I thought I'd like to be part of it.
So in Melbourne, we're going to recruit 100 to 150 subjects. We're looking for people over the age of 65 who are willing to have an amyloid scan. And then if that amyloid scan shows that they've got amyloid plaques in their brain, they're willing to go into this trial for 3 years.
Half will receive an antibody designed to remove those plaques. After 3 years, the team will assess if this has prevented memory decline.
These drugs work wonderfully in mice. Unfortunately, a lot of treatments work wonderfully in mice, but then are disappointing when put into humans.
Even though our DNA is set from birth, we can take positive action against brain disease.
Brain talks to the immune system, the cardiovascular system, including the heart. It talks to the endocrine system, all these hormones flowing through your body. And therefore, the two things that we all know are good for your body, physical activity and a healthy diet, are also good for the brain.
Those who build a brain reserve through exercise and complex mental activity can lower their risk of winding up with dementia by more than 40%. The question of nature versus nurture has traditionally been two quite different schools of thought on how the brain changes. But now, the lines are becoming increasingly blurred, opening up an extraordinary new area of brain science: brain epigenetics.
I think epigenetics is one of the revolutions that's going on within biology and medicine. Doing neuroscience at the start of the 21st century is like doing physics was at the start of the 20th century. It is the great frontier.
It turns out that although I don't remember my life before 4 years of age, my genes do. What I ate, how I responded to events, how my parents treated me, what I learnt, all placed chemical markers on my DNA. Those tags affect how my genes are expressed throughout my life.
We've known for a long time that the genome, it's about 3 billion letters of DNA, paired letters, and that's the letters of DNA in the genome, but epigenetics is above the genome. So without changing the order of letters, if you like a gene being a word, you're actually changing the emphasis by chemical modifications.
If you think of your DNA as a cookbook, epigenetics are the bookmarks that tell you which recipes are good to use and which ones aren't. Groundbreaking Australian studies have revealed extensive genetic tagging occurs in our brains during early childhood. There's evidence to suggest adversity during this time can tag our genes in a damaging way. Mice pups with inattentive mothers display changes to their genetic expression that make them more anxious and less likely to nurture their own babies. In humans, a 2008 study of the brains of suicide victims also revealed an abnormal level of epigenetic change in the hippocampus, particularly among those who had been abused as children. But, and here's the astonishing part, epigenetic changes can be inherited. Mice experiments at the Florey Institute have shown raising stress levels of male adult mice can lead to higher anxiety levels in their unborn pups.
If the levels of stress hormone in a father mouse are increased, then that will change the behaviour of the offspring, even if the father mouse hasn't been with the mother during pregnancy nor any contact with the offspring. But some information has been passed through the sperm to the next generation. And so the lifestyle activities and experiences of your parents may be carried into your body and your brain through epigenetics to the next generation, and that may be carried from you into your children. It's intriguing and it has huge public health implications.
It raises questions on how traumatic events may affect generations to come, or offer explanations on cycles of childhood neglect. But as bad experiences may affect genetic expression, so too do good ones.
There's evidence that none of this is permanent, including epigenetics. Some of it can be maybe not always erased, but compensated for. So we're now rethinking nature versus nurture. It's bidirectional.
When you think about it in this light, the very memories that make us who we are a complex combination of evolution, ancestry, experience, chemistry, chance, and the choices we make.
If nature is your genetics and your genome, then it can influence how you experience different lifestyles. Conversely, through epigenetics, your lifestyle, your experience, your environment can change how the genome's expressed. And everyone is a very complex combination of genes and environment, and it's not one or the other.
For more information on the upcoming Alzheimer's trial and the studies mentioned in this program, go to the Catalyst website.
Connect with Catalyst on Facebook, Twitter, Instagram, YouTube and our website.